So in this video we will learn how to integrate trigonometric functions, and specifically I'm going to focus on tan and secant in this video, since I focused on sine and cosine last video. And tan and secant are a bit more challenging than integrating sine and cosine. So first of all, we need to know the basic rules, which are as shown in the screen right now. So the integration of secant squared x is tan, and the integration of secant tan is equal to secant x, and these two are also important to know. So make sure that you write them down and remember them. Okay, so now let's start with this question. Now the other identity which is very important to remember is that tan squared x is equal to secant squared x minus 1. So this is another identity that we'll be using, and if you watch my other video of integrating cosine and sine, we somehow inject or replace tan or secant with the other identity so that we can use u substitution to cancel one or the other. So that is why, and we have to remember this, and we need to use this somehow. So now let's start with the question. So here I'm going to break the tan to the power of 4 into tan to the power of 2x multiplied by tan to the power of 2x, x to the power of 2 dx. Now we can replace tan squared with secant squared minus 1. So this is going to be secant squared minus 1 multiplied by tan squared x dx. And here what we are trying to do is we are trying to somehow break secant squared or secant into the equation so that we can use u substitution to cancel one of the variables. And here you might be thinking, why don't we just use u substitution here? So let's have u, and we're just trying this out right now, to be secant x. So du will be secant x tan x dx, and this will only cancel out one of the tans, and there would still be one tan left which we won't be able to integrate, right? And let's say if we let u to be tan x here, so du here will be then secant squared x, but still we won't be able to cancel this since this is secant x minus 1 and there's brackets. So this is why the u substitution here won't work, and you should be able to do this quick in your mind in order not to waste time. So we still need to do something to the integral to be able to use somehow to cancel one of the variables. So let's continue on. Now another thing you might be thinking is that we might be able to replace this with secant squared x minus 1, but in the end we will have secant to the power of x 4x, and this we cannot integrate, right? There's no integration for secant to the power of 4, so that also does not work. So here we need to expand the integral since we tried all the methods right now. So I'm gonna times it by secant squared times tan squared, and then minus 1 multiplied by tan squared. So it is gonna become, so we will have integration of secant squared x tan squared x, and I'm going to separate the integration since it's the same thing, minus tan squared x dx. So here, do you think we can use u substitution now, since we have secant squared x tan squared x? So here we can let u to be tan x, and du here will be secant squared x, and this will cancel out with this secant squared x, so that will work out for this integral. So let's do that. So here let's substitute u with tan with u, so it will become u squared, and we have a secant squared x, but here we will have du over secant squared since this part over here, and if you don't see that, we can do dx is equal to, we bring secant squared to the other side, so it becomes du over secant squared x, and this same thing over here. This is why the secant squared x will cancel out, and all we'll be left with is u squared du, and we can integrate this now, so it will become u3 over 3 plus, okay, I'll leave the c for now, we'll add that in the end. Now the next step is to know how do we integrate tan squared x over here. So there is no integration for tan x here, so somehow we need to change this into something else. So let's use the identity again. So this identity is used a lot of times, by the way. Tan squared x is equal to secant squared x minus 1. So let's replace that with minus integration of secant squared x minus 1, and we know the integration of secant squared is just tan, so this is just tan, and minus 1 will be minus x. So now I forgot to replace u here, so u was tan to the power of 3x over 3, and then remember that there is a minus sign over here. It will be minus into tan x minus x, and now we can distribute it, so it will become minus tan x plus x, and don't forget the c, the constant c. So this is the final answer. So you realize that we had to try a lot of methods here to get to the answer. There is no fixed one method kind of problem, especially for tan and secant. Let's move on to the next question now. So question 2, integration of secant cube x dx. Now this question is a bit more challenging than the last question, and here again let's split it in two parts and try to bring tan somehow. So let's do secant squared x times secant x dx. Now we can replace this part with 1 plus tan squared x, so this becomes 1 plus tan squared x, and there's a secant outside dx. Now we can try for u substitution here, but both of the u substitution won't work here since there will be something left over. So let's say if we take u as secant x, du will be secant tan, and although the secant will cancel out, or no, even the secant will become u, right? So there will be an extra u and it won't work out. And if we take tan as u, there will be a secant squared in the denominator, so there will be an extra secant in the denominator, so that also won't work out. So the only other option we have here is to multiply this and expand it. So it will become 1 times secant is integration of secant x plus the tan squared times secant is tan squared x secant x dx. Now one thing to keep in mind is that when we're doing f plus g, integration of f plus minus g dx, this is equal to integration of f dx plus minus integration of g dx. But although, let's say if we have integration of f multiplied by g dx, this is not equal to f, you can't split them and then multiply them. So integration of f gx multiplied by integration of g dx, this is not right, since this you need to use what is called as the integration by parts. And also same goes for integration over f over g dx is not equal to f over g integration. So keep that in mind. So here all we did is this part over here. So let me just erase this now. So now we know what is the integration of secant x, which is going to be ln absolute value secant x plus tan x. However, how do we simplify this now? We can try for u substitution again. So let u be, let's say, tan x, du will be equal to secant squared x, so this won't work out, since there will be an extra secant in the denominator. If we choose u to be secant x, we will have du as secant tan x, and this also won't work out since there will be an extra tan in the integral. So what do we do then? So what if we replace tan with secant squared x minus 1? This will come up to secant cube x minus secant x dx. And if you realize, we came back to the equation, right? So this is a good step, good thing that we see something like this. But however, the only issue that we have is that we have a positive sign to integral of secant 3x, and whatever we have over here is equal to this, right? The question is equal to secant dx plus blah 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 blah, and then we have integration of secant cube x. And if we bring this to the other side, this will become 0 and we won't have the question itself. So we need to use something else over here, some other method. So we need to come up with another method, because the method that we are doing right now won't work out, since we will always have 0 to the other side and we won't have integration of secant cube x. Actually what we need to see is something like minus, so that we can bring it to the other side. It becomes 2 integration of secant cube x, and then we can divide the other side over 2 and solve for secant, the answer, the question. So here what I'm gonna do is we're gonna go back a little steps here. So I'm gonna erase all this, and this is very common, by the way, when you're integrating secant and tan, since you don't have a fixed method. So here what are we gonna do? We're gonna integrate by parts here. So let's choose our u and dv, and if you don't know what is integration by parts, you can watch my other video I made it recently. It's just a formula and you need to remember. So here we're going to choose our u as secant squared x and dv as secant, sorry, it's the other way around. So u here is going to be secant and dv here is going to be secant squared x, since we need to derive u and we need to integrate dv. So we need to choose our u and dv very carefully here. So here du is going to be secant x tan x dx, and our v here we need to integrate secant squared x is going to be tan x here. And now we can plug in the formula, which is secant times the other v. So it's going to be u times v, so secant x multiplied by tan x minus the integration of v du. So tan x and then du here is secant tan. So we can just do squared here and then secant x dx. So now we notice that we had the same integral except that we had a plus sign before. So now we see some improvement, and here we can replace tan squared here with secant squared minus 1. So I'm gonna write this as tan as secant squared minus 1 into secant x dx, and we can distribute and multiply here. So this becomes integration of secant cube x minus secant x dx, And here I'm going to distribute the minus sign, and I'm going to make this the secant x to a separate integral. So this becomes secant x dx, and this also dx. And now we realize we came back to the equation. Sorry, but this time we can bring it to the other side and make it like 2 integration of the equation, and then divide both sides. So here we have the same thing, secant x times tan x minus secant cube integration, and then we have this part. We know the integration is equal to the equation, so secant cube x dx. We can bring this to the other side now, so here I can just cancel this out. This is 2, and then now we know that the integration of secant is ln secant x plus tan x, and this over here secant x plus times, sorry about my handwriting, I'm just trying to, and plus, and now we can divide this entire thing by 2 since we have a 2 here, and this is the answer, plus c. Let's move on to our last question, and it's a easy question compared to these two. So our last question is the integration of tan, actually let me write it, yeah, tan to the power of 4x times secant to the power of 4x dx. Here I'm going to use the identity of tan squared x plus 1 is equal to secant squared x. So let's replace one of the secant squared x with this part over here. So here what I'm going to do is I'm going to replace one of the secant with tan squared x plus 1 into secant squared x dx. Now you can always try to use u substitution and try to somehow cancel out one of the other variables. So here we can choose u, I'm just trying this out, secant x, and du here will be secant x tan x, and we realize that this won't be that helpful since it won't cancel out the tans. However, if we choose u as tan x, we know that du is secant squared x, and here we have a perfect secant squared x over here. So here this just would cancel out with this part, and we will be able to integrate. So let's write it down now. So u is tan, so it's going to be u to the power of 4 into u squared plus 1 into, I'm going to cancel it out, so it was dx here, and it is du over secant squared x, so this part cancelled out and we are left with du over here, and this is really easy to integrate now. It's gonna become u to the power of 6 plus u to the power of 4 du. So now it's gonna become u7 over 7 plus u5 over 5, and now replace u as what we chose over here, which was tan x, x7 over 7 plus u5, tan 5x over 5 plus c. And as always, I do have a shortcut method for you guys to recheck your final answer. So open your calculator, and you should have the integration sign or function on your calculator to be able to do this. So in your calculator you need to put two limits, right, for the integration. Let's just put 0 and 1 and integrate the question here. Just type tan to the power of 4x, and secant, you won't have secant, but secant you know is 1 over cosine, right? So put 1 over cosine x dx and just integrate it, and you will get something like 5.00730. And one more thing I forgot to mention is that you need to change your calculator angle unit, or let me check what this function is called. Yeah, angle unit. It is in your setup option button, and you click on angle unit and you change it to radian. This only works if it is in radian. So now you got the answer of 5.00730, and there's more decimals, but I'm ignoring them for now. In your final answer now, you're gonna replace 1 with x over here first, and then you are gonna minus it with the same thing over here, but replacing x with 0. And you need to use, of course, brackets, and you will get the same answer. So if you get the same answer, this means that this answer over here is 100% correct. And this also works for the other question that we did. And I will be, of course, making a short video on how to do this on the calculator, since it's of course more easy to show you guys rather than talk about it. So here I just type tan 1 to the power of 7 over 7 plus tan 1 to the power of 5 over 5 minus open brackets, and then you replace x with 0 this time, so tan 0, and then close brackets to the power of 7 over 7 plus tan 0 to the power of 5 over 5, and then close brackets, and you will get the exact same answer, 5.00730, and so on. So this is a method to recheck your answer if you have extra time in your exam. And if this is also a MCQ question, you can try all the options. Let's say you have A, B, C, D, and one of the options is this one. So it will take some math time, but you don't need to solve the question itself if you don't know how to solve it. I mean, I used to do this all the time. So that's it, I guess, and thanks for watching. If you have any questions, you can ask them in the comment section. I'll be more than happy to answer. And thanks for watching.